So Lieben's-Cert higher level differentiation for first principles. So as discussed, the slope is the change in y with respect to the change in x. And if you look at the graph over here, so we have our curve. And remember, we want to try and find the slope of our tangent. So our point x, f of x, and remember that f of x is the same as y, is one point on our curve, and it's the point at which our tangent hits the curve. And another point you pick on the curve is x plus h, which is some change in x because you've moved across the x-axis, and f of x plus h, remember f of x being y, and h being the change because you've moved up the y-axis, so it's f of x plus h, the change in the y value. So taking those 2 points, finding the slope of a line using the slope of a line formula, y2 minus y1 over x2 minus x1, and you can see that the x's are cancelled, so you're left with f of x plus h minus f of x divided by h. And the key is that the limit as h tends towards 0, so h gets very, very, very small but never reaches 0, and the closer you get, the smaller you make the h value, the change value, the closer you'll get to your slope value. What does that mean? So the closer you would move this point back here, so the h value here getting smaller and smaller and smaller, the closer you will get to your value of your slope of your tangent. Now, using differentiation from first principles, and so what I'm going to do is I'm going to do an example, and it's differentiate 5x minus 10 from first principles. Now, you're specifically told to differentiate from first principles, but before we even start, we know the answer to this is going to be 5. So we start off, f of x is equal to 5x minus 10. Next thing is f of x plus the change in x. Okay, f of x plus h. Everywhere you see x, you replace it by x plus h. Then take away your 10. Always simplify as best you can before you move to the next step. So 5x plus 5h minus 10. Next thing is you take away the original equation, and the original function was f of x equals 5x minus 10. So take away your f of x, and the easiest way to do it is just to change the sign. So it's take away your 5x, so it's minus 5x, and it's minus minus 10, so it's going to be plus the 10. I'll put the terms sitting under each other. So we add the two lines together, so we end up with f of x plus h minus f of x is equal to the 5x and the minus 5x cancel, and the minus 10 and the 10 cancel. We're left with f of h. Now remember from what we just derived for first principles, and that the next step is you divide f of x plus h minus f of x by h. So it's 5h divided by h, and you can see that that simplifies to 5. And in this case it doesn't really play any part, but f of x plus h minus f of x divided by h, and it's the limit as h tends towards 0. And I'll show in another example in a second what you would do if you have a h value here, but the answer is still 5. Now the second example is if you were asked to differentiate f of x equal to x squared from first principles. So step 1 again, everywhere you see x you add on the change in x, and everywhere you see x you replace then your x plus h, so it's going to be x plus h all to be squared. So work it out, f of x plus h is equal to x plus h by x plus h, and f of x plus h equals x squared plus 2xh plus h squared. So that's step 1 finished. Step 2, take away your original equation. So you're taking away x squared, that's all you have to take away. So add the two lines together, so you end up with f of x plus h minus f of x, and your x squared and your minus x squared cancel, and you're left with 2xh plus h squared. Step 3 then, divide by the change, which is h. So f of x divided by h, which is 2, and take each term individually. 2x h divided by h plus h squared divided by h. It's easier for cancelling. So f of x plus h minus f of x all divided by h is equal to, your h's cancel and one of your h's goes out with your squared, so you're left with 2x plus h. Now the last step is the limit as h tends towards 0. Okay, so remember, the smaller the change, the closer you're going to get to your value for the differential. F of x plus h minus f of x divided by h, and everywhere you see h you put in 0. Okay, so it goes closer and closer and closer to 0. It never reaches 0, but we put it in as the value 0. So the answer is 2x. So when we differentiate x squared from first principles, we get an answer of 2x. Now one more example on it. If you had f of x equal to something like 2x squared plus 3x. So f of x plus h is equal to 2 by x plus h all to be squared plus 3 by x plus h. Bit of working out, so it's 2 into x plus h by x plus h plus 3x plus 3h. So f of x plus h equals 2 into x squared plus 2xh plus h squared plus 3x plus 3h. So f of x plus h equals 2x squared plus 4xh plus 2h squared plus 3x plus 3h. So that's step 2. Step 1 finished. Okay, now step 2, take away your original equation, minus f of x. Okay, so you're going to have minus 2x squared and then minus 3x. So adding your two lines together, f of x plus h minus f of x equals, so your 2x squared and your minus 2x squared and your 3x and minus 3x cancel. So you're left with 4xh plus 2h squared plus 3h. Step 3, divide by the change, which is h. So it's 4xh, remember taking each term individually, plus 2h squared divided by h plus 3h divided by h. Cancel where you can. So we're left with f of x plus h minus f of x is equal to 4x plus 2h plus 3. Okay, and remember that it's divided by h, and now it's the limit as h tends towards 0. So it gets smaller and smaller and smaller, so small that we're considering it to be 0. So 4x plus 2 by 0 plus 3, which gives you a differential of 4x plus 3, which you would have seen from the start, 2x squared plus 3x giving you differentiating to 4x plus 3.